Law of cosines occurs when we have two sides and included angle, or all three sides. Chapter 8, Section 3, Law of Cosine. Use when you have two sides and then included angle or all three sides. So it's side, 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 angle, side. Here are the formulas. C squared is A squared plus B squared minus 2AB cosine theta, or same angle, C. B squared is A squared plus C squared minus 2AC cosine bravo A. B squared plus C squared minus 2BC cosine A. So whatever side you're looking for, it's that angle that's in the cosine. And the other two that's needed inside there. Let's look at the first example. Example 1. A equals 2, B equals 3, C equals 60. So we need to get angle A, angle B, and side C. So side C is C squared equals A squared plus B squared minus 2AB cosine of 60, which is 2 squared, 3 squared, 2, 2, 3 cosine of 60. What's that going to be? So C is equal to square root of 7. All right, now how do we find angles A and B? So we need angle A, we need angle B, we have angle C, and we have side C. So to get angle to get angle A, we need to have A squared equals B squared plus C squared minus two BC cosine A. A is 2 squared, 3 squared, square root of 7 squared. We have to isolate the cosine A. 4 equals 9 plus 7 minus 6 radical 7. Subtract 16. Change the signs. So cosine A is equal to 12, 6 radical 7. How do you get rid of the cosine? Yep. Take the inverse cosine of both sides. So angle A is equal to you can simplify this. This could be 2 over, so it's 2 over radical 7. So what's angle A? So the inverse of cosine of 2 over radical 7. So more like it, yeah. It's so C is equal to 60. So B is equal to 180 minus 79.1 minus 60. 20, 21. That's 41.9. Yeah. So those are the angles. Or 40.9. Yeah, the cosine function is a lot more friendly because it deals with only one angle. The rest of it is just integers. Oh yeah, let's look if we had all three sides. Example. A is 4, B is 3, C is 6. So we have to find all of the angles. Let's find angle A. Because we're looking for angle A, we have to have A on that side. So we have 4 squared, 3 squared, 6 squared. Change the signs. So cosine A is equal to 29/36. The inverse cosine, that gives us angle A.
You go.
Because whatever angle you're looking for, that variable has to be, that side has to be on the equal side. And then all the other leftover sides are there. But what you did wrong last time?
Yeah, I did. I had to break it down first. And
Okay. So what's this angle? Have it? Approximately 36.3.
then-
So that's 36.3 degrees. To do B, we need B squared. So we have A squared plus C squared, 2AC cosine B. Squared plus 6 squared, 4 times 6. cosine B is equal to 43/48. Oh, wait. All right, that's two down. And we're done with calculations. Now we just do the 180 minus those two. Six, 3, 2, 6, 4. Gotta be.
I know, I was looking at that. 3, 4, 6.
So 180 minus, it's gotta be 0.3, right? There. Any questions about cosine functions? Let's look at it. Applications now. Correcting a navigational error. A motorized sailboat leaves Naples, Florida, bound for Key West, 150 miles away. Maintaining a constant speed of 15 miles an hour, but encountering heavy crosswinds and strong currents, the crew finds after 4 hours the sailboat is off course by 20 degrees. How far is a sailboat from Key West at this time? Through what angle should the sailboat turn to correct its course? How much time has been added to the trip because of this? Okay. Speed is 15 miles per hour. Naples, Florida to Key West equals 150 miles. Okay, A. Distance to Key West. Angle to correct. Time left. Okay. The distance to Key West. So what do we have? We have, here's our picture. We're starting off from Naples. The Key West is down here somewhere. Distance of 150 miles. And it's off course by 20. Because so how far is the ship after 4 hours? How far is it from Key West? And what should you correct it? All right. So we have So the distance from here to here is 150. After 4 hours, 60 miles. Okay, now. Turns to 4 hours is off course by 20 degrees. But it's going to be here. It's going to be 60 miles. I want to know that distance. A. Hmm.
Would you be able to use the sign like 20? That's not.
Only if it was a right triangle. Because when we do the SOHCAHTOA, it's with a right triangle. But since this is an obtuse angle, can't use that. Now I gotta figure out, okay, I have the complete distance from point A to point B is, that's the distance we're going. B, I gotta figure out this one. That's 60 degrees. I mean, 60 miles from here to here. Actually, what would you get if you tried that?
I have no idea.
Try it, try it. Yeah, but we wouldn't have the hypotenuse though. Well, we have that. We have this one here.
Like that stretch from.
From here to here.
You know cosine. You know cosine is one, that's opposite, that's not. You know, I mean, you know, A. Or B.
Yeah, we're looking at the opposite. Okay. Okay, that could work. Yeah. That- what's 150 squared?
22,000.
Zero, zero, one. Okay, cosine of 20 times that. So what does that give us?
Did you add a zero onto 18,000?
Was 15 times 6 is 80 with two zeros behind it, yeah. Or 20. Yeah, it should be only two zeros. Oh, that's 80 times 2 is 30. 30 times 6 is 180 with two zeros.
Oh, was 18. That's 30 times 6 is 180 with two zeros. Yeah. So what's the value gonna be?
Yeah, yeah, so 96.
Yeah.
Okay, so square root that you get.
Oh, sorry, B was 96.
Oh, B is 96. So it's 90 miles away. 96 miles away. So we have that. What's the next one I seen? So what course should it now sail towards? We have to know this angle. So we have B, we have 96. So we have little b is 96, capital B is 20. We can figure out this angle here, call that A. C is 60, so we can find angle A. We have to find the angle they have to travel towards now. So what's all this stuff inside there? Because we have to find angle A, because that's the direction they have to travel to get to where they're going. what's the value? We have 96 squared plus 60 squared minus 2 times 96 times 60. And this is 150 squared.
Which, I'm trying to find the.
Now we're trying to find the direction they have to fix it. So we have a squared equals b squared plus c squared. So this is 150. So now, yeah, we have to do that to get our angle to return to Key West. Not that squared. Right, so that's where we're off course. So we have to do 180 minus our A, which is 180 minus 147.2. We're 32.8. Because we're heading south for 20 degrees off south. So this is the direction we're heading. We now have to correct our course by 32 degrees. How much more time will take? So that's B. So that's the correction of the course. C is How much time has been added to the trip? So we have 60 miles our first one. We have 96 to go. 6. So we travel how fast? 15 miles an hour? So it'll take us less than half an hour. That's why they went off course the first off. Where are we supposed to go? Yeah, I think when I was taking flight training, we had to do this sitting down with what we call it an E6B. It's not a calculator, it's a rotary dial. We have to do all these calculations in the airplane, and so it does get pretty scary. Nowadays, you have the Garmin's. You type in a number, it'll tell you exactly what you do, where you have to correct your course so you head directly to where you're supposed to. Oh no, well that does it for that one. Woo! I'm sorry, everybody. You're right. That took way too long.